Hello everybody, today we're going to talk about animation, so let's get started. So let's talk about animation. What we want with animation, we don't always want to do like recreate a film or actual movements of animals or people, that sort of thing. We're just trying to liven up our presentations or our websites. We can put static information on there, and a lot of times that's what people want, but other times we want to make things more attractive, so we make it move or do some fun things. So to begin with, life is measured continuously. I mean, we don't think about individual movements. We think about moments, we think about times and that sort of thing, but when we actually think about somebody playing a musical instrument or running along a field or something like that, it's continuous movement. But modern video equipment and electronics, we're talking about discrete things, things that are saved digitally, and so it's not a continuous type of thing. We talk about frames, and then what we try to do is make it look like movement by flipping through the frames. If we have a fast enough frame rate and small changes between the frames, then we get the illusion of motion. Okay, there's different ways of presenting animation on a website. We can just take video footage with a video camera or however you want to record it of actual life movement, and then we can play it back in an HTML canvas, and that's what you're probably seeing here, unless I've posted it on YouTube. Not really sure about what I'm going to do there yet. The next thing we can do is we can use JavaScript within a canvas to draw things and then erase them and draw them again to make it look like there's some sort of animation going on there. There's also macro languages people have created that you can create some sort of a starting description, what it looks like, and then give it rules for how things move, and then it takes care of creating the animation. But for this course, what we're going to be doing is the middle one. We're going to be using JavaScript to draw the frames. Okay, next let's talk about the tools, the HTML5 canvas that we're going to use to draw, and that's pretty straightforward. The JavaScript that we're going to use is going to make use of some of the methods that are built into the canvas, and we're also going to use jQuery, not unlike what we've already done, just to provide access to the DOM and use that onload or ready function. Okay, the jQuery, we already talked about the ready function. Now the resize and attribute methods are going to allow us to redraw the canvas every time that the user changes the size of the browser. This is important because otherwise what happens is that the image is too big for the window and things go out of the screen, or it becomes too small for the window and you got a lot of wasted space. So this makes it much more pleasant for the user to look at, and also using the tags or the $sign to access the HTML elements that we've done before. Okay, the context methods that you're going to be using that are part of the canvas object include two methods for changing the color: fill style and stroke style. So fill style changes it for when you fill an object, and stroke is for when you stroke it, and that's just the same as drawing in other languages. Just think about doing the outline of a particular object. Okay, so there's fill rect and stroke rect to draw triangles, and then other objects are drawn by using lines with a path. So you start a path, draw any kind of lines that you want to define that, and then when you close the path, then wherever you are at in your drawing and the beginning, it draws a line between there, so it finishes that way. So once it's closed, then you can fill it to display a shape. Alright, so these are examples of drawing, like in this case a circle. So the first thing you do is get a variable assigned to your canvas HTML object for this first line here. Then the next thing you do is get the context. This is the object that you use to actually draw things. And then I'm changing the color on it and just picked some arbitrary color here. And then next I start the path with the begin path method, and then I draw an arc, and the arc actually closes itself because well, I'll explain that. So with the arc method, you pass it, the first two variables are the center of this arc that you're drawing. So this is going to be at x equals 10 and y equals 25. It's going to have a radius of 15, and then the last two variables tell it the starting and ending, like, radians of this arc. So I'm starting at 0, which is, you know, the line going off to the right from the center of the circle, and I'm having it go 2 pi, which is a full circle radians. So if you'd set it to just pi, then it would go half a circle. And then after I close this path, I fill it, and that completes the circle. Alright, so let's look at a quick example to show this. In all of the examples that I'm going to be showing you, I'll have an HTML file that will have some, the header information will have some style at the top, just some real quick CSS, and then I'll have a script tag that imports the jQuery library, and then another script tag that has all of the JavaScript that I'm putting in there, and then finally the body of the page will be down at the bottom, and that's going to be something as simple as possible, usually just a canvas statement. Alright, so in this particular one, inside of the ready function, I grab the canvas, and then I use the get context to get the context of it, and then I define the resize method here. So every time they resize it, I go out there and find the inner width and the inner height of that, and then set the canvas to those two things, and then just clear it. And then I call that resize canvas down below here, and then I have another method that's outside of the ready function, and I call that inside of the ready function with the draw shapes. And so the draw shapes is just going to draw a rectangle and a circle. We can take a look at that right there. Alright, moving along, we've got a quick slide that's kind of a recap on the JavaScript code. We create the canvas object, we use JavaScript to get that and to get the context, and then we use the context methods to draw the object. One thing I want to remind you of is that the origin in most computer drawing programs is in the upper left, which is different from what you normally think of as being in the lower left, but just remember that and it should be okay. 0, 0 is up here, and then as you go to the right, X gets larger, and as you go down, Y increases. Now for doing animation, naively you might think that the best way to do it is just to create a loop, like an infinite loop, where you just keep redrawing the things and moving their locations on the screen. But if you do that, it just happens too fast, and with the CPU doing different cycles and having to do lots of different things, it can get very jagged, and so it's much easier to use the timeout in JavaScript, that we can control it for a certain number of milliseconds. The basic format of timeout is set timeout, and it takes a function. So the function is what it's going to execute after so many milliseconds that you put in here. So a lot of times what you do is you put in an anonymous function here, so you define the whole thing all at once. But that just does one, that just sets the timer once. What we want to do is we want to keep setting it over and over again. So the accepted way of doing that is to use recursion, where we have a function, and then you do whatever it is that you want to do repetitively inside of here, and then at the end you set the timeout to execute this same function over again after, you know, the desired number of milliseconds. So let's see a couple of examples of using the timeouts to control it. The first example is just using text. It's not going to use a canvas at all. The second example will. Alright, so in my ready function here, I've got a function called start time, and that really does what I want it to do, which is basically just going to display the hours, minutes, and seconds. And so I use a variable to get the hours, minutes, and seconds from the today object, and then I have a method down here, or a function down here, that just adds a 0 if it's a number less than 10. So it looks like the time as we're used to seeing it. And then I just simply update the element down below that I want to with those numbers. And here's where I do the recursive call. I just set the timeout to be half a second, and then to call this function over again. I use half a second because if I made it every second, there's a chance it may miss a second here or there. So using half a second guarantees that you're not going to miss any. And so that example looks like this, not totally unexpected. And then the next example is going to it's going to show a square moving across the screen. Very simple. So all we do is we get the canvas context like we did before. We do the resize, and then the actual function we're going to look at here is animate. And so in the animate, it just does this set timeout function, and the anonymous function in there is going to clear the entire rectangle and then draw a border around it, and then it's going to call this draw square method, and then turns around and calls animate again. It's going to do this every 20 milliseconds. Alright, the draw square, what that does, it just fills in the style, fills in the or it just changes the style, fills in the rectangle at a particular spot, x keeps changing, and then I add 10 to x, and I return it so that x gets updated up here. So let's take a quick look at that. Okay, so moving a square across the screen is interesting, and you can imagine doing different things rather than just moving the x coordinate, but there's a couple other important things that we need to talk about before I can really set you guys free to let you start working on something. So first thing is starting and stopping, and we're going to just let the user determine that by clicking on the screen. And when the code, what we want to do is we want to keep track of, are we moving or are we not moving. So we create a flag or a variable that's just set to 0 or 1. We'll let 0 mean that the animation is not on, so nothing is moving, and 1 means it's on. And then inside of that recursive function that we've created, we'll have an if statement that checks to see if it's on. If it's on, then we go ahead and execute the drawing statements inside the inside of that function. And if it's off, then we don't. And then we have a click method on the canvas to change the animation flag. So let's take a look at an example of this. Pretty much the same example as we saw before, but now we've got a variable called motion. It's defined, let's see, I can't remember where it's defined. There we go, up here. So I assume that we're going to right away start animation, so I set motion equal to 1, and then inside of this loop, if the motion is 1, then we carry out those things. Otherwise we basically just exit this this function. Then I associate a click event with the canvas, and if the motion is equal to 0, I change it to 1, and then call this animate to get it started again, and otherwise I change it to 0. So let's take a look at that. I click, it stops. I click, goes, I click, it stops. Okay, exciting stuff, huh? Okay, now we've got some of the basics down. What I'm going to want you to do for this next assignment is I'm going to have several different objects on the screen for you to animate, and I'm going to suggest that you use objects. And so each time you create a new thing on the screen to animate, use an object to represent it. And the object can have properties like its location and other properties if you want. And then it's also a good idea maybe to put a method in there to draw, to describe how to draw it. Then you can just very simply in your code for the animation just put in a loop and then draw each one of those objects. And that makes things much simpler for your code. Okay, one last thing is the refresh rate. Sometimes your application may redraw things every 10 milliseconds or so, but the refresh rate may be 16 milliseconds, more likely. And so what happens is you're doing more work than you need to. Like every once in a while, you're drawing something that is not actually going to be seen on the screen. It's not going to actually update it until this next one that you draw over here. So there's something called a request animation frame. What that does is it fires an event every time you get a new animation frame. And so if you implement that, it helps to save the battery and cut down on CPU cycles. So I'm going to show you how we do that, and then show you a couple other examples as well. So this example is basically going to do the same thing as the other example did, except for I'm using request animation frame instead of using the set timeout. And so everything else pretty much looks the same, but in this method here I have an animation ID, or you can use whatever you want here for a variable, but you got to get the ID that this get animation frame returns. You don't need it for requesting the animation frame, but we're going to need it for canceling it down here. And so every time this returns true, there's a new one, it will call the animate function. So we'll call this one again. I can put it in the top here because it's asynchronous and it doesn't get called until there's one available. So in the meantime, I will go ahead and clear the screen and then redraw that square at a different location and keep changing it like I did before. Then whenever the user clicks on the canvas, if the motion is stopped, then I'll set motion to 1 and I'll request a animation frame again. If it was already moving, then I'll set it to 0 and I'll cancel the animation frame. So I get it started and stop it like that. Start it and stop it. So take a look at this again. Start it, and as you can tell, it goes a little bit smoother. So we've got that going for us, which is good. For our next example, let's take a look at changing something besides just the X. So in this example, everything's all the same except for the fact that now I'm also changing the Y. And so instead of passing it an X value, I'm just passing it the count. And the count just goes from 0 up to whatever, takes me to the end of the screen and beyond. And each time I set the X equal to the count, so this object will just move across the screen like it did before, but the Y is going to change. And rather than just having the Y move down or something like that, I thought it'd be more interesting if we used a function like a sine function to have it go up and down. And so it will take the sine function of that variable and it will take the, what I do here is I adjust it by dividing it by pi, because I want a number that's going to go between 0 and pi. So I take the sine of that number, and that's going to give me a number between -1 and +1, and then multiply it by 100 just to exaggerate the effect of that sine function. And I also add 100 to it too, because I want to start it down somewhere. If I didn't do that, then you'd only see half of the wave function. So let's quickly take a look at that one. And okay, it's kind of what you expect, drawing a nice little sine function there. Alright, stop it, and let's go back here. And now I want to modify this so that it changes not only the y but also the x. So instead of just having the x value increase, I'm going to change it so that the x value responds to cosine. So it's going to up and down as well as left and right. So I do that just by changing the x value. Instead of just setting it equal to that count, is I use a cosine function. So it'll vary like the y value does. So I can take a look at that quick, and you just get this action of moving in a circle. So you can do all kinds of fun stuff like that with the different trigonometry functions. The next example will show you how you can bounce off the walls. It's not very much fun if the objects just keep going off the screen. So like in a lot of games, we want them to bounce off the walls. And for that, we just have a simple rule that we put in here when we draw in the square. If x gets to be less than 10, so it's over here on the left hand side, or if it's greater than the canvas width -10, I put that buffer in there so it doesn't actually go off the screen. Then what I do is I change this x change value. So that's going to either be -1 or 1. If it's going to be 1, then it's adding to it and it's going to the right. When it gets over here to the side, close to the edge there, I multiply it by -1, so it becomes a -1, and it starts heading back this way. And then again, when it hits this wall, I multiply by a -1 again, and so it starts going back this way. And then I just keep adding that to x, whether it's negative or positive. And then those are defined up here as global variables. So let's take a quick look at that one, and it will just simply bounce back and forth forever. That's exciting. So let's take a look at the last example. In this one, I'm pretty much doing the same things as I've done before, only I'm changing the y value also. So the x value is just going to keep increasing by 5, but the y value is going to do something interesting. It goes down to a certain point until it gets to the floor, which is going to be 400. And when it gets to that point, then I multiply, instead of multiplying by a -1, I multiply by a -0.8. So this is reducing the amount at which it changes. So every time it gets down to the bottom and hits the bottom, it comes up, but not as high as it did before. So it's kind of simulating gravity. And the other way we simulate gravity too is that as it's coming up, I make its speed get slower and slower. So I'm making that change be 1/10 of what it was before. So let's take a look at that last one. So there it goes. That sort of looks like it's behaving according to gravity. At least to me it does, maybe not to you guys. And if you want to be more exact about how you have it react to gravity, then you've got to get a little bit more mathematical about it. But as you can see, we're getting pretty close. Okay, so that's all I wanted to show you. Don't worry, you don't have to use gravity for the assignment that I gave you, but it's out there and you can get started on it. And as always, if you have any questions, just let me know. Good luck.